Yeah. Now, this is the introduction and the ways to graph the exponential function. What are the exponential function? I have already shared with you two stories. One was for the a penny a day salary structure. Second was the chessboard story. It's available in your web bell ringers page. You can still watch it on your own, go through the presentation. In week 5, I can show you again over here. In week 5, this was the link provided in your home. If you will go to modules, in the modules over here, bell ringers page, I missed it. In the bell ringers page over here, this is the link for story time exponential functions. This is a link for the presentation, the slide, Google Slides. Watch it and then move back to the lesson. That's the reason I have here the chessboard with the grains of rice. Each box, the grains of rice are doubled. Read the story and you will know the reason why is it there. Now we are talking about the growth. This guy who's climbing on the financial growth is representing, again, in the real world, exponential functions. It can be the viruses, bacteria in the lab, exponential growth of the population, and other things that we have seen in the presentation and in the video in Nearpod. So with all these, now in this session, we will work on the basics of exponential key attributes. Let's do it. First thing, we will fill in the blanks here. Your names should be on this worksheet. This worksheet should be submitted in Canvas as your current week grade also. I will first of all write the exponential function in a very simple form, and then I will generalize it also. Anything where 2 raised to power x or a number raised to power x is mentioned, that will be an exponential function. So keep it in mind, whenever an exponential expression, the base is a constant and the variable is in the exponent. You see, you can refer to this whiteboard also. Anything when it's written in the form a raised to power m. On this whiteboard, a raised to power m, the a is called a base, and whatever is the power is called an exponent. So on the screen, 2 raised to power x is in the exponential form, 2 is a constant, x is a variable, an exponent is in the exponent, the variable is in the exponent. How will you write generally the function that we are going to discuss now? y equals, I'm intentionally writing it in different colors. A is the product times B, and B is the key letter over here, number, key number. It will tell us a lot of stuff. B raised to power x. A times B raised to power x. This is a simple form of an exponential function. I have not brought in the h and the k here. Normally we have worked on h and k and an a every single time when we were learning the quadratic functions, cubic functions, and h over there was telling us about the left and right movement. K was telling us about the vertical up and down movement. We'll bring those also shortly, but let's first write down what will this function tell us. Just the B, I'm looking at B and I'm filling in the blanks. The blanks are exponential functions are defined by an equation of the form. I have already mentioned the equation over there. No harm in mentioning it one more time over here. This is the equation that you can always consider as an exponential function, or it can simply be y equals b raised to power x also. Both are the same thing, nothing different. Or as the numerical example, you can take it as y equals 3 raised to power x. All these things will be called equations of the exponential function. Now, if I'm looking at the b, look at this. This was the yellow highlighted b. Agreed? And I have written it with a, without an a, and then I wrote a number instead of a b there also. If b is a 3, is it greater than 1 or less than 1? It's greater than 1. And this case is the first one over here, which I'm saying if b is greater than 1. So we are determining based on b that the function is an exponential function. This will be an exponential function. What type of an exponential function? Keep it in mind, this will always be a growth. Whenever you will have b greater than 1, a 3, a 2, or a 4, that function will be a growth. And the second case, if the same b is less than 1, what can be an example of that? Let me write it over here. If we have a y equals 1/2 of an x raised to power x, 1/2 raised to power x, nothing changed. Even this function is satisfying the basic characteristics of an exponential function, a number raised to power a variable. So this is an exponential function. We will first of all call this an exponential function. An exponential function, no harms, function remains the same, but this will not be a growth, this will be a decay. What do we mean by a decay? The range will keep on, like the y variable will keep on getting decreased. It will decay. And if I will look at the plot of these two exponential functions, the growth case and the decay case, how will it look like? I will bring in the growth case over here, a small plot in this corner. You see the blue function with an increase in value of x, y is keep on increasing. This is a growth. This function is growth. When a graph will take this shape, whenever the b is greater than 1. And what will happen if the b is less than 1? I will give you an example in the shape of a plot also. And we saw that by less than 1, it can be a half, it can be a 0.2, 0.25, anything like that. And in that case, the function will be plotted something like this. You see, it's going down. When it's going down, that's a decay. When it's going up on the right side, that's a growth. Is it difficult? Just b is telling you where an exponential function will end up. Will it keep on growing exponentially, or will it keep on decaying exponentially? Okay, that should make sense. Now, I will generalize this function also. By generalizing, no, instead of generalizing, I want to introduce here the terms which will move the function left or right, up and down. Let's do it. So those are the h and k. I'm writing down the function again over here in the exponential function form. How will I do that? Y equals a times b raised to power x. Again, I will mention an x over there. And if you remember, every single time we will including the h with an x, whether if it's an absolute function or a quadratic function, cubic function, h was always getting together with an x. And then k was always an independent term. So k will be separately written over here. That means If I will look at the comparison, the function in the box, if I will take this here, h is a 0, k is a 0 because it's not mentioned over there. H is a 0, k is a 0. Got it? Take notes from this screen, and just based on this information, we will now be able to work on the questions in this worksheet. I will give you an example and I will tell you how can you do that. We will determine what's an H, what's a K. We will determine how the A will impact the curve, and then we will determine based on the B if it's a growth or a decay. Now, before doing that, I will show you it on the Desmos also. Let's look at the Desmos screen. I will bring it up here in Desmos, looking at three different shapes. So here and here. The function here you can see is a 3 raised to power x. Whenever it's a 3 raised to power x, you see it's getting an asymptotic shape along the x-axis and then keep on increasing. Here the b is greater than 1. That means it's a growth. Here the b is a 3. Whenever b is greater than 1, we will see at a growth exponential growth. When b is half, 1/2, which is less than 1, let's see how will it look like. I will remove the function which was a growth. I will bring in the function which is a decay. You see, the decay is going downwards. With the next increased, it's keep on getting smaller and smaller. Y is getting smaller and smaller. And this point is a y-intercept. You see the y-intercept? 0 and a 1. What was the y-intercept in case of the first growth function? Again, y equals to 1 is a y-intercept, 0 and 1. Now, we have discussed when b is greater than 1, when b is less than 1, both are the exponential function. What will happen if the b is 1? Let's check this one. It will not be an exponential function. For b equals 1, it will not be an exponential function. It will just be a straight line. Keep it in mind. Now, we will go back to our notes and work on an example. Asymptote. Let me give you a general characteristic. Horizontal asymptote, in this case, will always be at y equals k. That will tell you where is the asymptote. Y equals k is the horizontal asymptote. About the range and domain, that's what we will determine now. Can I move to the next thing, the example of utilizing all these things? Let's go there. Here is the first example. Based on this exponential function, we will now determine if it's a growth, a decay, if it's a domain, if it's increasing or decreasing along the axis based on the values of b, a, k, and then h. So looking at this, what do you see? What's the b? Greater than 1 or less than 1? Greater than 1 because it's 2. And obviously it's greater than 1. Based on this, what can we determine? Is it a growth or a decay? It will be a growth because b is greater than 1. Simple. Whenever b is greater than 1, it's a growth. And before going further on the same question, look at the bottom, the second question, question number 2. What's the b there? 1/4. Is it greater than 1 or less than 1? 1/4 is less than 1. That means for the second question, that will not be a growth, that will be a decay. So whenever you will have a b greater than 1, that's a growth. Whenever it's less than 1, that's a decay. Now what's the h here? 0, because it's not mentioned definitely. H should have been somewhere over here. It's a 0. What's the k here? 0. So k is also a 0. Now the domain. Domain is easy for exponential functions. You know, it will always be all real numbers. Domain is all real numbers. And in set builder notation, I can simply write that x such that x belongs to this sign over here. We will read it all the time. Belongs to what? The real numbers. All real numbers will be the domain of the exponential functions all the time. What about the range? Remember the k that we determined? Range will always be y greater than the k. Don't put here the k itself. I'm just telling you y is greater than k will always be the range. And we do know the k here is a 0. So y greater than 0 is going to be the range. What is the y-intercept? If I will put here, and if I will create a table, that can definitely help me to determine the plot as well as the y-intercept. So let's think about x being -1, 0, 1, 2, and a 3. For -1, if I will substitute it over here, for -1, 2 raised to power -1 will be 1/2 or a 0.5. You can use the calculators for that. 1/2, and that's going to be somewhere over here. At this point, 1/2. And then for 0, the plot will be at 1. When x is 0, you can use the calculators. 2 raised to power 0 will always be a 1. 2 raised to power 1 will be a 2. 2 raised to power 2 is going to be a 4. And then keep on going. 2 raised to power 3 is going to be an 8. 8 will be somewhere over here. I will connect these dots and that will give me the plot of the function. It's clearly a growth. And where did it intersect the y-axis? Over here, which is y equals to a 1 when x is a 0. So we got the 0 and a 1. And where will be the asymptote? I told you k is always going to give me the asymptote, and k here is 0. So y equals to 0 is my asymptote. All characteristics that we are interested in for exponential functions can be found in this way. Okay? That should be helpful to work and complete the worksheet.